Our goal for 5.5 is to solve quadratic equations by graphing or by a table. So there is some differences between a quadratic function and a quadratic equation. So I'm going to show you those right now. In standard form, a quadratic function would be f of x equals ax squared plus bx plus c. Now, it could be f of x or it could be y. So those could be used interchangeably. If I'm talking about a quadratic equation, then it's set equal to 0. There will be no y in my equation. There will be only one variable. The only variable that will show up would be an x, and then that means you could solve and get x alone. However, when you have, and we talked about this when we were trying to solve for x-intercepts last in part 1 of the unit, when you have an x squared term and an x term, you can't work to get those by itself because there's no way to combine x squared and x. So instead, we're going to have to figure out, and that's what this part is, part 2 of this unit will be, is to how to solve when we're dealing with a quadratic and you have more than one term with x in it, and they're different types of x that you cannot combine, like x squared and x. So that's what we're working on this unit. The standard form of a quadratic equation is actually this. So we should actually write that there, and then we'll actually define what a quadratic equation is in that spot. So let me erase this. So a quadratic equation, it's similar to a function. But it is set equal to a number instead of f of x. So then that example would be like 0 equals ax squared plus bx plus c would be our standard form of a quadratic equation. The roots, zeros, solutions to a quadratic equation, all of those terms are going to be used interchangeably, so you'll want to make sure you recognize each of those, because if something's asking for a root or something's asking for a 0, you want to make sure you understand what it is you're looking for. This is just the value of x, so the solution of x, that makes the equation true. So the value of x that makes the equation true. So let me kind of give you an example here. Okay, so here I did this example. This would be the equation. So you can see it's in standard form. It's an equation because it's set equal to a number. It's in standard form. It's set equal to 0 already. If it wasn't set equal to 0, let's say this 28 wasn't on this side and it was 28 equals x squared plus 3x, I could move the 28 over this side so it's set equal to 0. Anyways, when I were to solve this, the solutions, what they should be is x equals -7 or x equals 4. So what happens is the -7 and 4 are roots, zeros, or solutions. So whenever we're asked to write a root, 0, or a solution, it's going to look like this. X equals a number. So what we can do then is I want to show you that if you plug this in here, you end up getting 49 minus 21 minus 28, which does equal 0. So that's why this is a solution, is because it makes this equation true. When you plug it in over here, this side is equal to 0. 0 equals 0 works. If you plug in 4, that turns into 16, and this turns into 12. So 16 plus 12 minus 28, that's also 0, so that also would work. So that's kind of your example of what it is we're talking about and what these will look like. So we are going to solve by graphing. So in order to do this, what we're going to do is we're just going to pretend that this is actually a function. So we are instead going to graph f of x equals x squared minus 3x minus 4. Now, this is what we did in part 1. You guys worked at graphing that. So the first thing that you're going to want to do is you're going to want to find your vertex, or your axis of symmetry. X equals the opposite of B over twice A. So there's your vertex, is at 3/2. So here we're going to make our table. We know that 3/2 will be the middle. We have to plug that back in to figure out what the y value of that is going to be. When you plug that in, you're going to get negative 6.25. I'm not going to be super picky about that because that's just the vertex for our table. We're going to plot it here in a minute anyways. 3/2 is 1.5, so that's in between 1 and 2. So plug in 1, you're going to get negative 6. Plug in 2, you get negative 6. Keep adding numbers in. Plug in 0, you're going to get negative 4. Plug in 3, you're going to get negative 4. I'm going to add in another row here. Okay, so I added in another row. So when you plug in negative 1, you're going to get 0. And when you plug in negative 2, you'll get 6. So then what we're going to do is we are going to plot these. So you can see here I've made my scales on my x-axis go up by halves because I only need to go to, I'm going to have to go to 5. I'd have to continue this. I didn't have room on here, but I know that if 0 matches with 3, I also have to go 2 past that, so 4 and 5 will be on here. So I also went to negative 2, so all of my numbers fit on here. Notice I didn't go up by 1s because then I would only go to about here on my graph and here on my graph. And I want to take up as much of my graph as I can, so I go up by 0.5s instead. I do have to go up to 6 and down to negative 6. So I made sure I can go up to 6 and down to negative 6 and a little bit more, because that 0.25, that quarter, past that. So if I go up by 1s on the y, I should be able to handle that. Make sure I finish my labels here. I'm going to plot all these points. So negative 2 is at 6, negative 1 is at 0, 0 is at negative 4, 1 is at negative 6, 1.5, which is 3/2, which that's easy to plot on here because of the fact that I went up by halves. So 1.5 is easy to find on there. And then I keep going. 2 is going to be at negative 6. 3 is at negative 4, and I'm just going to use my mirror image points to continue this. So 4 is at 0, and 5 is at 6. And I'm confident in those mirror image points because I already checked a couple of them, so I know if I keep going, it's just going to keep working. Okay, so then what I'm going to do is I'm going to connect all these. I'm going to make sure that when I connect them, I do it nicely, a nice rounded U-shaped curve. And there is my graph. Now, when I go to write my solution, this is not my solution. My graph is what it's allowing me to graph my solution. So remember, I actually graphed f of x equals x squared minus 3x minus 4, right? It's right here. So this is what I actually graphed. Now, instead of graphing, because I couldn't graph this is replacing y, I replaced the 0 with f of x, or I replaced 0 with y, depending on if you wrote this y equals x squared minus 3x minus 4, or f of x equals. I usually write f of x equals because I like function notation. However, your y is replacing your 0, so where is y 0? Y is 0 anywhere along this x-axis. So where does the graph hit this x-axis? It hits it right here and right here. So what are those points? What are the x values? Because remember, that's what we're looking for in our equation. What are the x values that make this equation true? And our x value at the first point is x equals negative 1, or x equals, at this point, 4. Now what you can do is you always want to check to make sure these are accurate. So negative 1 squared minus 3 times negative 1 minus 4 is supposed to equal 0. Put this in your calculator, or let's work it out. 1 plus 3 minus 4 is 4 minus 4, which is 0, equals, on the right side, I have 0, and I am confident that that works. So I checked negative 1. Now what we're going to do is we're going to do the same thing, but with 4. 4 squared minus 3 times 4 minus 4 equals 0. Simplify it on the left. 16 minus 12 minus 4, that's 4 minus 4, which is 0, equals, the right side was just 0. That one also works. So I checked both of them. So what you're doing is you're going to graph this. Your x-intercepts are actually going to show you your solutions. Now, when we're looking for a solution, we have to write it x equals a number. If this had x-intercepts, I would not write it like this. Instead, I would have negative 1, 0 and 4, 0. There is a difference between a solution and an x-intercept. And you have to be careful, because when you have your quiz, if it's asking for an intercept or a solution or a root or a 0, that depends on how you write the answer. All right, so solving using a table. This next one, we are looking for a solution of an equation, and we're looking for, remember, like up here, 0 is replacing f of x. So we're going to look on the f of x column, and where would 0 fall? 0 would be here in between 12 and negative 1, and then it would be again over here between negative 3 and 8. So the way that we write these ones, we can say x is between these two numbers, negative 3 and negative 2. Or x is between 0, between these two numbers, because this is your x. X is between 0 and 1. Those are your solutions. So when we are solving by graphing or solving by using a table, you're going to make sure your equation is set equal to 0. Then you're going to use the graph or table and graph the similar function. And then you're looking for the x-intercepts to find the value of x. Your solution is always written as x equals a number. And so you have a couple options here, because sometimes when you go to graph this, maybe your parabola is above the x-axis and goes up, or maybe it was below the x-axis and goes down. In either of these cases, if you got a graph that looked like one of those and you had to write the solution, you're going to write no solution. I guess I should actually put that in the box that's provided. Now, sometimes when you go to graph, you're going to notice that the parabola touches, I didn't do a very good job on that one, it touches at that vertex. So that lowest point is on the x-axis, or maybe the parabola, the vertex of the parabola, the maximum, that highest point, is right on the x-axis. If that is the case, these ones, you're only going to have one solution. So you'll have x equals a number. If it's no solution, you just write no solution. The third option is the vertex is below that x-axis and it's going up, which means it has two x-intercepts. Or if your parabola were to look like this, you also have two x-intercepts, meaning you'll also have two solutions. So here are some reminders and steps on how to graph. So to graph, convert to 0 equals ax squared plus bx plus c. If it's not already set equal to 0, you have to make sure you do that. And then you're graphing f of x equals ax squared plus bx plus c. If this was a number, let's say I put a 4 here, you cannot do that because then you're not looking for where y is 0. You'd have to look to see where y is 4. So to be consistent, we always keep it a 0 there, so that way you're always looking where y is 0, which are your x-intercepts on the graph. To graph, you have to first find the vertex, then find surrounding points. So you're going to find your vertex. In order to find your vertex, you also have to find your axis of symmetry. To find the vertex, your x value is the opposite of b over 2a. Plug that in. That's all that says. Plug in x to the equation, and then you'll have that. That's a typo right there. That should be negative b. So let me just make sure. That's just a negative b, opposite of b over 2a. So you're just, whatever you get for x, you're plugging that in for y. Then you're going to use the x-intercepts to find the solution. You're going to check your solution by plugging it in. Remember, x-intercepts are always written x comma 0, where root 0 or a solution is always x equals a number. So make sure you know the difference between what an x-intercept is and a root 0 or a solution.